When you're used to other object-oriented programming languages, one thing you're probably missing is an easy way to create by-reference classes. The standard LabVIEW classes are by value, and sometimes you need more than that. The OpenGDS will make this process a lot easier. OpenGDS stands for Open GUB Development Suite, which is nothing more than a tool set to make the process of creating by-reference classes and other class templates a lot easier. In this Did You Know, I'm going to show you what this toolkit can do by creating a music player class, which you can use in all your projects. After downloading and installing the OpenGDS, you can get this new item when you right-click on your target called GUB Class. This will open up a dialog where you can configure your class. We can give it a name here, and in this example we will call it Music Player. For class provider we use the GUB4 by reference template. This template makes by reference classes using data value reference. In this field you can set its inheritance, and right now we don't have any other classes in our project, so the only object we can inherit from is LabVIEW object. One of the things we want this class to have is a parallel process, where our music player runs. To add a process to a class, we have to add a design pattern by pressing this button. This will extend the dialog where you can pick a design pattern to add to this class. We will choose the active object dynamic events to and from process. This will give us an active object with the possibility to create methods which send or receive data from the active process using events. Now that the configuration is done, we can create the class by pressing the Create Class button. This will show us a dialog to set the icon of the class, and you can press a random button a few times until you find something you like, but we will use the default one and press OK to continue. The next dialog will show the settings regarding the active process. If you are creating multiple active processes in one class, you need this dialog to customize the method names. Because we don't need it right now, we can just press OK. Now that our class is created, we can open it up and see what methods the GDS created for us. In the root of the class we have three methods: create, destroy and control process window. The create and destroy make sure the class is created and destroyed properly. The control process window method is a helper method for the active process. With this method we can easily open up the front panel of the process VI for debugging, or maybe even show it as part of your design. When we look at the code behind this VI, we see that there is a user event sent. This event is received in the process. As we look again in the class, there is a utils folder containing two VIs. The new VI is used for initializing the data value reference, and the get reference is used to get the DVR reference or even the attributes cluster. Looking at the protected folder, we see a few VIs and some controls. The control object attributes is where you place your class attributes. For now there's only one attribute in here. The other VIs in the protected folder are the active process and its helper VIs. The only VI you need to edit is the process VI. Leave the other VIs as is. The process VI contains a modified version of the JKI state machine where you can add functionality for your class. This process is running until you destroy the class. So if you want to have something running in the background, you can create it in here. In our case, this is the place where we are going to create the Windows Media Player control, which is going to play our music. After placing the Windows Media Player control on the front panel, we can create a constant from this control. To use it in our class methods, we need to copy it and paste it in the object attributes control. As you can see, there is already a numeric control called attribute1. This is the default control which was automatically generated during the class creation. This is to ensure the code is runnable. Since we don't need it for this application, we can just delete it. Now that the control reference is in our attributes, we can create a property method to set its value. To do this, we need to right click on the class and select GUB, Add Method, and this will show us the Add Method dialog. With this dialog you can easily create property methods for your attributes. And in our case, a method for accessing the media player reference. We want to create a private method to get and set the value, so we select both the get property and the set property. We set the access scope to private because we don't want anyone who uses this class to change this value. Let's move the methods to the private folder so it's organized. Now we can use this method in our process to save the reference of our control in our attributes. We want to do this as soon as the process starts, so let's navigate to the core initialize case in our state machine. Here we need to make some room to insert the set media player VI and control of the media player. After inserting the set media player VI on the class reference wire the media player control into this VI. For this example, this is all that the process is doing. Now we have to think about the functionalities we want our class to have. So one of the things I want my music player to have is a playlist functionality. And other things I want my class to do are play a song, stop a song, go to the next song, go back to a previous song, add a song to the playlist, remove a song from the playlist, and clear the playlist. Let's create methods for these functionalities. These methods should be accessible from VIs outside of the class, so all of these methods should be of the public access scope. Let's speed up the video while I create the empty methods. Now that we have created the empty methods, we can start programming the functionality we want. So I talked about wanting to have a playlist. So for that we are going to add a few controls to our attributes. We want to maintain a playlist, and the easiest way to do this is by having an array of path controls. Let's call this array playlist. We also need to know what index is currently playing. So for that we're going to add a numeric control. Let's call this control index. We also need to change the data type to U32. Now that we have these attributes created, we're going to implement the method. So the first thing I want to do is add songs to my playlist. For this we open the add playlist method. Because we're going to change the playlist data, and to keep it simple, I'm going to create a private get and set method for the playlist attribute. We're going to use these two access methods to get the current playlist array and add a new path to this array by writing it back into the setPlaylist method. If you want to make this foolproof, you normally should check if the file exists and has a certain supported file type, but this will do for now. We should always make sure our methods have clean code, even if it's just two sub-VIs. This makes reading back old code a lot easier. After adding the build array, we need to create a file path control on the front panel and hook it up to our connector pane. The only thing left is to wire it back into the build array, and we're done with this method. After adding items to the playlist, we also want to remove an item from this playlist and clear the playlist. So let's implement those methods as well. For the remove from playlist method, I want to search for the path in the array and remove the index of the found item. So first we're going to get the playlist array from our attributes and do a search 1D array with the file path control as element to search for. After the element is removed, we need to write the new playlist back to the attributes. So we'll insert the setPlaylist method for this. We draw a case structure around the setPlaylist method and wire the arrow wires, and don't forget to wire the other cases as well. We are going to wire the index of the search 1D array VI into the case selector and check if the value is greater or equal to 0. Let's make some room so we can delete the item from the array. Wire the current array and the index of the item we should delete, and store the array without the deleted element in the attributes. The clearing of the playlist is fairly easy. and we're doing that by writing an empty path array back into the set playlist. With this code, the playlist is done and we can move over to implementing the play method. Instead of creating accessor methods, you can also use the get attributes to easily get the data from the attributes. To play music, we need the media player reference, the playlist and the index. First thing we need to do is to get the current index and get the file path of that index out of the playlist array. Check if the file path is not empty, and after that we're going to use the property node to get a property from the media player. With this property node we're going to set the URL of the current song, and after that we're going to start the song by getting the control and invoke the play method. Draw a case structure around the property and invoke node, wire the arrow in the other case and connect the empty string check to the case selector. Draw a case structure around the property and invoke node, wire the arrow in the other case and connect the empty string check to the case selector. To set the correct URL, we need to change the property node URL to a write and wire the path into it. Because the URL needs a string, we simply need to convert the path to a string. The only thing left in this VI is making the current case the false case. Now we need to implement the stop method. We are doing this almost the same way as we invoked the play method. With the property node we get the controls of the media player and we invoke the stop. Now the only thing we need to do is implement the next and previous methods. For the next method, we're going to use the playlist and the index attribute, which we are getting with an unbundle by name from the get attributes VI. To skip to a next song, we are simply going to increment the index unless the current index is greater or equal to the amount of items in the playlist minus 1. If that's the case, we are setting the index back to 0. To demonstrate that it's also possible to set values without creating accessor methods, we're going to use the in-place DVR structure. From the get attributes VI, we can get the DVR reference and wire that into the in-place structure. And with a simple bundle by name, we can set the new index in our attribute. To automatically play the next song, we call the play method at the end. If you only want to play the next song when there's already playing another song, you need to implement this yourself. And for the previous method, it's almost the same as the next method. It's just the other way around. In this method, we are also setting the index with the in-place DVR structure, which needs the DVR reference from the getAttributes VI. After getting the playlist and the index from the getAttributes VI, we need to check if the current index equals 0. If so, we can set the new index to the amount of items in the playlist minus 1. If not, we decrement the index. Just as with the next method, here we are also calling the play method after setting the new index in the attributes, so that the previous song will automatically play. The only thing I want to add now is a method for getting the current song, so you can see which song is playing. For that, we create a simple method called getCurrentSong and create and open it. We are going to index the playlist to get the song path, but we not only want to get the output of the song path, we also want a readable song name without the extension. For this, we are going to use the getFileExtension VI. Now we only need to link the two indicators to our connector pane, and this method is done. Because creating the main VI is fairly simple, I sped up the process. So first we're going to create some buttons to test the methods play, stop, next and previous. To read the current song, we need a text indicator, and to read the current playlist, we're using a list box. For the bottom row, we add buttons to add, remove and clear the playlist, and a final button to exit the application. Now we only need to hide all the labels, and the main front panel is ready to test our class. On the block diagram, we're going to create a while loop with an event structure inside. For each button, I'm going to create an event and add the button to the event case they belong to. In the exit case, we also need to wire the stop while loop so we can actually exit this test VI. Now that the main VI is ready, we need to create the class. We do that by dragging the create method from the project explorer onto the block diagram. Because we need the class wire in all our event cases, let's wire it through the while loop and event structure and create shift registers. To speed up the process of drawing all the class and error wires, we're going to create a linked input tunnel and select create and wire unwired cases. So now all our cases are wired. In the timeout case, we want to update the playlist list box with the getPlaylist method. So when we look in the class, we see that the getPlaylist method is private, but for us to use it in our main, we need to make it public. We can easily move it from the private folder to the root of the class and change the access scope to public. By default, all OpenGDS private methods have a white background for the icon, so you can easily see it's a private method. To change it back to the public background, the GDS provides an icon editor to quickly change this. As you can see, the background color of the icon has changed back to the class color. Before creating the code for filling the playlist, we are going to show the current song name by using the getCurrentSong VI and wire the output into the current song string control. To fill the list box with the playlist, we need to create a property node to set the item names and change that to writable. To convert all the songs in the playlist to strings, we're going to iterate over the playlist items and use the getFileExtension VI to get the file name without extension, just like we did in the getCurrentSongName method. We wire it out of the for loop with indexing enabled and feed it into the property node. Every time the time structure goes into the timeout event, the playlist and the current song control gets updated. To add songs to the playlist after pressing the add button, we want a file dialog with a filter for music files. Here we can configure which files can get selected, and we uncheck the limit selection to single item because we want to select more files at a time. For the filter we only want MP3 and WAV files, so we add this string constant to the pattern input. For the pattern label, we create a string constant with the text music files. To add them to the playlist, we use the addToPlaylist method, and we draw a for loop around this method because the dialog can return multiple file paths. After adding a song, we also want to remove a song from the playlist. Let's place the getPlaylist and the remove from playlist methods. I want to remove the current selected song in a playlist, and for that we need the value of the playlist control. So we create another property node from the playlist control and select value. With the value we can get the current index, and by using the index array we get the song matched to this index. Now we know the path we want to remove, and we can call the remove from playlist method with this as input. The rest of the button events will get their matching methods, and because these methods don't need any input from the user or the UI, we can simply call them. As you may have noticed, we cannot run this VI yet because the run arrow is broken. Let's open up the error list to see what's happening. The create VI has an error, and when we look at the block diagram, we see that there is an unknown variable unbundled and bundled again. We know that attribute 1 does not exist anymore, and we also don't need to write any values here, so for now we can remove this. We have one more error to fix, and this one is on our destroy VI. We also need to remove the unbundle of attribute 1 from this VI. Now that the errors have been fixed, we are missing one thing, and that is the destroy method when our program is finished. Now we can finally test our class. First we're going to add a few songs to our playlist, and when we press the play button, the music starts playing. We can press the next and the previous buttons, and the next and previous song starts playing. Let's see if we can remove an item from the playlist. And last but not least, hopefully we can stop the music as well. Now you know how to create a simple class with an active process. Thank you for watching, and we'll see you in the next Did You Know?